Hi everyone, thanks for tuning in. My name is Mirko Datta, I'm part of the Lagon development team, and today we're going to have a look at some of the neat features we bundle within the Lagon development environment. But first, let's have a look at the agenda for this screencast. We're going to start by looking at the build structure of a sample project named Chirper that is available within our GitHub repository. Then we will see how you can run all the services projects defined within that build. And last, we will see how you can integrate with external Lagon projects. Now let's explore the SBT build for the Chirper project. In the first line, we're setting the organization for the old build so that we don't have to repeat it for every project. On line 4, we're setting the Scala version that is going to be used by all projects in the build. Even if you're going to use Java in all your projects, you still need to set the Scala version. This is needed to resolve some of the Lagon dependencies. Be reassured you won't need to write a single line of Scala in your code. Finally, we get to the interesting stuff, the project declarations. Chirper is made up of 4 services. A friend service handles users and relation among them. A chirp service for creating and retrieving messages from users, also known as chirp. An activity stream service to retrieve history or live chirps of a user. And a front end, which is just the web UI for the Chirper application. There is actually also a 5th service, which is used for load testing. Because it doesn't play a role in how the Chirper application works, we will ignore it in this screencast. Now that we know what each service does, let's have a closer look at how they are defined in the build. The first thing you'll notice is that every service is broken up into 2 parts, an API project and an implementation project. The API project is generally very simple. Let's take as an example the friend API. As you can see, it only declares its version and has a single library dependency to the Lagon Java DSL API. Your API project will likely look very similar, if not identical, to this one. However, note that project is a utility method that we define in our build, and it's not available in the stock SBT, but you can easily define it in your own build if you find it useful. Then let's move to the friend implementation project. First, note that the implementation projects are marked with the Lagon Java SBT plugin. You can see that on line 13. This is really important, so don't forget to enable this plugin on all your Lagon implementation projects. If you wonder why that is so important, you'll see it really soon. Second, we have a few settings for the project. The first settings declaration is again declaring the project version and listing the needed library dependencies. Because the friend service needs to persist data in a database, it's using the Lagon Java DSL persistence module, while the Lagon testkit module is useful for writing tests. The second settings declaration is needed to correctly execute some of the tests. Third, since in this project we want to provide an implementation for the friend service API, it is only natural that it depends on the friend API project. The Chirp API and implementation project look pretty similar to the friend one. Instead, the activity stream implementation project is very interesting. The activity stream service communicates with both the Chirp and friend services. For that to be possible, the activity stream implementation project needs to add both the Chirp and friend API project to its list of dependencies. That is indeed all you need to do to enable one service, in this case the activity stream service, to communicate with any number of other services defined in your build. In this case, both the Chirp and the friend services. Last, we have the front-end project, which in our case is a plain Play project. If you're not familiar with Play, Play is a high-velocity web framework for both Java and Scala. If you're interested in learning more, head out to playframework.com. Play is a natural choice for us as it allows us to deliver truly reactive web applications. Having said that, you don't have to use Play if you don't want to, and you're absolutely free to pick a different web framework of your liking. After all, the Lagon services you'll be building may not even need to be consumed by humans, so there may be no need to create a web UI in the first place. After having explored the Chirper build, let's see what the Lagon development environment has to offer you. Alright, let's move the terminal cd to your project root, and then just type SBT to enter the SBT console. Once the project is fully loaded, you can run all your Lagon services with a single command, run all. As you can see, before starting your Lagon services, a number of other components are started first. In fact, the Lagon development environment embeds a Cassandra server, a service locator, and a service gateway. Cassandra is the default database in Lagon, and for conveniency, we have embedded one in the development environment. Even though it's a single instance shared across all services, each service is going to use a different Cassandra key space, so services are effectively isolated from each other. The service locator enables communication across your services. Upon start, each service will register itself to the service locator by providing its name and address to reach it. This all happens automatically, and no configuration is needed on your side. It just works. The service gateway is a proxy that is useful for calling your services endpoints without knowing their actual address. After the above components are up and running, your Lagon services are started in parallel. Note that only the projects that have enabled the Lagon Java SBT plugin or the Lagon Play SBT plugin are started by the run all command. At this point, all the services are up and running. To check that this is indeed the case, let's open the browser and access the Chirper application via the web UI. You should note that the actual port used by the frontend is 2818, as you can see in the terminal. We have a front-end project here that is running on 2818. So why can we access it on port 9000? The reason is that we're accessing the front-end through the service gateway, which is running on port 9000 by default. You should also note that ports are assigned consistently to each service, meaning that if you stop and restart a service, the same port is selected. That again happens automatically, without you having to manually specify ports for each of your services. Of course, if for some reason you'd like a service to run on a specific port, you can do that via the Lagon service port project setting. But in general, you should not need to worry about it. The great thing about having ports assigned consistently is that you can create scripts that exercise your services, and you could even share these scripts, since the same port are consistently assigned not just on your machine, but on any machine. Now, let me show you the number one feature of the Lagon development environment. Your services aren't just simply running right now, they're actually running in hot reload mode. To demonstrate the functionality, let's go in the IDE. I've imported the Chirper project into Eclipse, and now I'm just going to make a change in the source. It's safe. And if we go back to the terminal, we see that the project is being recompiled and also automatically reloaded. This is an incredible productivity boost, since you can stay entirely focused on your task and let the Lagon development environment take care of the rest for you. Let's assume that a different team than ours is responsible for delivering a Hello World service. Their build file may be similar to the following. What we want to achieve now is integrating the Hello World service into the Chirper build, so that when we execute the run all task in the Chirper project, it will run also the Hello World service. Good, so let's integrate the Hello World service in the Chirper build. Let's open the Chirper build file, and then anywhere, doesn't really matter where, declare the following. We're going to use this method called Lagon external project that requires a name. This is going to be the name of the project. And then a dependency. And a dependency, it's simply the dependency to the Hello World jar file. And the version, we can check it back in the Hello World build file. So we're using version 1.0 snapshot. And this is actually simple.helloworld, as we can see here. All right, this is all it's needed. Now we go back to the terminal and we press Ctrl-D to start the services. This is going to shut down the Cassandra server. It's going to shut down the service locator and service gateway. And it's also going to shut down all the services that are currently being run. Good. Now we need to reload our build. And once the build is loaded again, we are going to run again the run all command. And this time we should see that the Hello World service is running together with all the other services. Okay, and as you can see, now we have an Hello service running as well. So we managed to integrate the Hello service into our Chirper build. To verify that this works as expected, we can open the browser and exercise one of the endpoints that is provided by the Hello service. And as you can see, we get an answer, so it all works. There are other interesting features available in the Lagon development environment, so I'd encourage you to have a read of the Lagon documentation. We also have more screencasts available covering both the service and persistence API, and one demonstrating how easy it is to run your Lagon services in production with Conductor. Make sure not to miss them.